In this video, we're going to use Allium, the AI skill for expressing behavioural intent, to build a new application from scratch using only spec-driven agentic engineering practices. We're going to start in a directory that only contains an AGENTS.md file. This is a standard file used by AI tooling, and we'll use it to store information about our desired technology stack, non-functional requirements, and the engineering principles we'd like to prioritize. This guidance will be useful when we come to implement code later. Our application is going to track debts between individuals. It'll track what you owe to your friends and what they owe to you. We'll call it Nudge. Allium is a skill that works with all major AI harnesses. Here we've installed it into Claude Code, and we're going to ask it to elicit a specification for our application idea, starting with the following prompt. I'm building Nudge, an app for splitting expenses between friends. You add an expense with who paid, how much, and who was involved. The app tracks who owes whom. Let's use Allium to elicit a specification. One of the appealing aspects of agentic engineering is expressing ourselves with human language. However, one big disadvantage of normal speech is that it's fuzzy. Despite our best efforts, we're often imprecise about the things that we mean, and conversely imply things that we don't mean. To mitigate these two opposing risks, people have conversations with each other. When someone is receiving information from another person, they usually benefit from actively listening, repeating what they've heard in their own words, and asking questions to clarify anything that remains uncertain. The elicit subskill guides AI to behave the same way, to enter a dialogue with us to make sure we have communicated clearly what we mean. As you can see, our initial prompt left several areas of uncertainty, and the model comes back to us with follow-up questions. We go through several turns of questions and answers to nail down exactly what it is we're trying to achieve. Sometimes the process of articulating our intentions highlights implications that we didn't initially consider. This is totally normal, and the objective of the elicit process is to identify exactly these areas and to help us reason through the consequences of our design ideas. It's not necessary to provide answers to every question. In fact, it's likely that open questions and deferred details will remain. The purpose of this process is not to fully specify your whole system up front. It's to describe a particular area of functionality well enough so that we can say with confidence when our goals for that area have been achieved. Following the back and forth, we've now got to a point where the AI believes we've sufficiently defined what the core behavior of our application is supposed to be. It will write a file into our project directory which succinctly captures this behavior in an unambiguous formal language. We're not expected to read this file or understand the language it contains. Its audience is the AI. The file exists to make sure that we haven't left any relevant areas undefined. The AI calls out to the Allium command line tools that we have installed and checks the spec. Rather like drawing a diagram on a whiteboard, the act of externalizing information sometimes highlights areas that it turns out are not as clearly defined as the AI believes. If this is the case, it will come back with further clarifying questions. As you can see, the specification is not a fixed artifact. It's dynamic, evolving context that will be updated and extended as new information comes to light or our objectives change. Now that we've provided some additional details, there are no outstanding open questions. Our project contains two files now, our new behavioural specification, nudge.allium, and the agents.md file we started with. These two files are sufficient context for us to delegate the implementation to AI. To do this, we're going to use the propagate subskill. We'll issue the following prompt. Let's propagate the happy path into implementation and tests. Read agents.md for our developer guidelines. We're going to fast forward over the implementation because it takes about 2 minutes. Once the implementation is complete, our AI reports that we now have 10 passing tests. Whenever we've made significant changes, either to the specification or the implementation, it's always a good idea to run the weed skill, which will check that both agree with each other. Our weed instruction returns 3 findings. The first 2 are most important. A divergence with the spec has highlighted a bug in the code, and another issue with the code has highlighted that our spec should be more precise. Once we describe our preferred solutions to these issues, the AI begins updating both the spec and the code to bring them into alignment with each other. The issues raised highlight the value of this workflow, using elicit, propagate, and weed in regularly aligning the spec, code, and tests with each other, and with our own intentions for how our application should behave. This isn't big design up front, though. We've identified potential bugs to fix and ambiguities to clarify in a tight feedback loop. We stay close to the consequences of our decisions. I hope this video has encouraged you to try out Allium. You can get the code from the Juxt plugin marketplace at github.com/juxt/claude-plugins and read about how to get the most out of it at juxt.github.io/allium. Healthy code grows from clear intent.